Okay, in this video I'm going to go through question 4 and 5 of the Unit 1 assessment. So I'll put a link in the video description of the time at which I start going through question 5. So if you're just stuck on question 5, you can go straight to that. Okay, question 4. Gold is a very soft metal. In order to make it harder, goldsmiths mix it with silver. The quality of gold is indicated in carats. Okay, so that's a new word. And if it's a new word, then it's probably going to be a problem-solving question. And in problem-solving questions, the question will give you all the information you need to answer the question. So don't be thrown off by the fact that you might not have heard about carats. You probably have heard the word, but you might not know about carats. Don't be put off by that. Just think, right, okay, this means I'm going to have to read the information in the question very carefully. Okay, so A, the graph shows information about the quality of gold. So we've got our graph here. We've got quality of gold in carats, so we can have 2, 4, 6, 8, all the way up to 24 carats. And then we've got different axes. This is an unusual graph because we've got an axis on each side. So we've got percentage of gold, and we've got percentage of silver, and then we've got a line drawn across the graph like this. Okay. And the question then says, what is the percentage of silver in an 18 carat gold ring? Now, if you spotted this axis, brilliant. You can go across and you can go, well, 18 carats, that's up to this cross here. And then you can work out the percentage of silver based on that. Now, most of you got this spot on, but some of you were a little bit careless with the way you followed this cross across to the axis. So the middle of the cross, I would say, is right between those two lines there, if you look at it carefully. Okay, so the top of the cross is there and the bottom is here, but the middle comes out bang on between these two lines, grid lines on the graph. So we're coming out at exactly between 20 and 30. So we're coming out at 25% silver in an 18 carat gold ring. If you didn't see that axis and you went across and you went, well, 18 carats, and then you took it across to the percentage of gold, you'd have come out with 75. So you could have maybe worked out 75% gold must mean it's 25% silver, but I think most of you spotted this axis here. So that first part of that question was fairly nice and easy. This next part was more difficult, and a lot of you did struggle with this. And what I'm going to do is I'm going to set some more tasks this week for everyone to do some more practice of this type of calculation, because once you get the hang of it, once you do a bit more practice, hopefully you'll be able to get it next time it comes up in an assessment. So part B says silver tarnishes in air, forming black silver sulfide Ag2S. Silver tarnishes to form black silver sulfide Ag2S. Okay, fair enough. And it's giving us an equation. So the equation for the reaction is 4Ag plus 2H2S plus O2 makes 2Ag2S plus 2H2O. Now, whenever you get an equation, it's worth having a think about what the different symbols mean, right? Just from the question, silver sulfide Ag2S, it tells us that, so that's silver sulfide. And if you didn't know already, it might be worth looking up any symbols in the periodic table for anything that you didn't know. You should recognise a lot of these, so you should recognise water, you should recognise oxygen. H2S, you might not recognise, that's hydrogen sulfide, but you should know that that's a compound with hydrogen and sulphur in it anyway. And then Ag, you probably would recognise that as the symbols for silver, but if you didn't, you could look it up. So that's silver. And then the question says, what mass of silver sulfide would be formed from 1.08 grams of silver? So it's asking what mass of silver sulfide would be formed from 1.08 grams of silver. Now, the first thing with this type of question, we've got a balanced equation, and it's giving us some quantities. So this is suggesting to me, and this is also a 3-mark question. Whenever you see 3 marks, they're quite uncommon in National 5, and usually quite often a 3-mark calculation is going to be one of the what we call calculations from balanced equations. So we've got a balanced equation, it's a 3-mark question, that's saying to me calculation from a balanced equation. When we're doing a calculation from a balanced equation, there's a few set steps that we need to follow. The first thing to do is to figure out what substances in the equation it's talking about. It's asking what substances is it asking about and what substances is it giving you information about, because it's never going to be asking you about all of them. So we've got to think about what substances the question's about. So it says, what mass of silver sulfide, so it's about silver sulfide and it's asking us about the silver sulfide, would be formed from 1.08 grams of silver. So it's giving us information about the silver. So I would always circle the two substances in the equation that the question is all about. And then you've got to think about what is it asking and what information is it giving. So I would write out a data column for both of the different substances. So I would always write the name of the substance, silver sulfide, and then I would write silver over here. Okay, so what is it asking about? Well, it's asking about the mass of silver sulfide. Okay, and we don't know any other information. And for silver, it is giving us a number in grams. You should know that grams is a mass. So you should know that it is telling us that the mass of silver sulfide is 1.08 grams. Okay, now some of you just forgot a little bit about how to do the question and started just trying to go from one mass straight to another mass. The way I've taught you to do this is we would just call it like going via moles. So even though it doesn't say anything about moles in this question, if it's a 3-mark question, if it's one of these calculations from balanced equations, you're going to have to use the number of moles to work out the answer. So even though I don't know, it doesn't say anything about moles, I should work out, if it's a 3-mark question, if it's a calculation from balanced equation, that I'm going to need to work out the number of moles for the substances in this equation. To work out the number of moles, I've got 2 different possible equations I can use, going back to the data book. So to work out the number of moles, I've got N equals CV and N equals M over GFM. C is concentration and V is volume. M is mass and GFM is gram formula mass. Now, the question in this case doesn't say anything about concentrations and volumes, but it does have mass. And you should remember that you can work out the GFM from a formula. So, I'm going to be needing to use N equals M over GFM to work out my number of moles. And I knew that because I'm given information in grams, which is a mass. So I'm going to finish off my data column with my GFM. So silver is just going to be 1 times the formula, the relative atomic mass of silver, which is, again, you need to look in your data book for this. So silver is going to be way down here, and it has a relative atomic mass of 108. So GFM of silver is just 1 times 108, so that's 108 grams per mole. So remember, the GFM is the mass of 1 mole. So I'm looking for N, and at the moment I don't have anything about silver sulfide, but I'm probably going to need to use the same equation because I'm asked for the mass. So I'm looking for the number of moles of silver, N equals M over GFM, which is 108 divided by 1.08. Oh no, I've just done that the wrong way around, haven't I? So this is why you should always go and double check your calculations. So the mass was 1.08 grams, and we're dividing that by 108. So if I do that, 1.08 grams divided by 108, which is the GFM, that tells me I have 0.01 moles of silver. Okay, so we have gone through the steps for this calculation before. So step 1, I would describe as calculating the number of moles for the thing that you had the most information for. So we had the mass of silver, and we've calculated the moles of the thing we had the most information for. Step 2, the second thing, is going to be to use the mole ratio. So step 1. Step 2 was the mole ratio. So the mole ratio is given by the balancing numbers in front of the different substances in the equation. So we're talking about silver and silver sulfide. So I always like to write down the symbols. So silver and silver sulfide, the mole ratio is going to be 4 to 2. Now, you should recognise from maths that would simplify to a 2 to 1 ratio. So if I know the number of moles of silver is 0.01 moles of silver, and I'm trying to find the number of moles of silver sulfide, well, if it's a 2 to 1 ratio, to go from 2 to 1, I'm just dividing by 2. So if I do 0.01 divided by 2, then I would get, it's given me 5 times 10 to the power of minus 3. So you could either write that, or you might recognise that that's 0.005. Okay, so my first step was to calculate moles. My second step was to use the mole ratio, and then my final step is going to be, now that I've used the mole ratio, that tells me that my moles of silver sulfide is 0.005 moles. So 0.005 is my moles of silver sulfide. I don't know the mass, but I could work out the GFM for that. Ag2S. So again, GFM for that one, sulfur, if you look in the data book, I think it's 32, so 1 times 32. And this time in silver sulfide, we've got 2 silvers, so we're going to do 2 times our 108. So that's going to be 216. 216 plus 32 is 248. So our GFM for silver sulfide is 248 grams per mole. Okay, and then we're going to use this equation again. So N equals M over GFM. But we don't have to calculate the number of moles this time. We're calculating mass. So you can do your triangle if you want. Mass is on top. It's on top here. So we're looking for mass this time. So to find out the mass, we're going to do N times GFM. So 0.05 is the number of moles times by the GFM, which is 248. So if I do 0.005 times 248, that's going to give me a mass of 1.24 grams and that's of silver sulfide. Okay, so my working's got a little bit messy here. I've shown quite a lot of working, but I've double underlined my final answer to make that nice and clear. So that was my final step. My final step was to, once I've used the mole ratio, to use the number of moles to calculate back into whatever it's asked me in the question. So I'm using the number of moles and the GFM here to calculate the mass of silver sulfide, and that's what it asked me in the question originally. Okay. Question 5. So question 5 says a solution of sodium carbonate of accurately known concentration can be used to determine the concentration of an acid by carrying out a titration experiment. So sodium carbonate, blah blah blah, concentration of acid, titration experiment. Okay, so that's given me an idea that this question is all about the acids and alkalis topic, titration as well. So 5A is name the salt formed when sodium carbonate reacts with hydrochloric acid. If you didn't get 5A, you need to just revise naming salts because that should be a fairly easy question. So when we're naming a salt, the first part of the name comes from the metal in the base. The second part of the name comes from the acid. So sodium is the name of the metal in the base, and hydrochloric acid would form a chloride salt. So the answer to question 5A is sodium chloride. 5B, this again is just remembering, just memorising that titration experiment, just making sure you know all the pieces of equipment. So name the equipment that is used to measure the volume of sodium carbonate added to the acid. It even gives you a little picture here. So this thing here with the sodium carbonate in it, that one is the burette. You wouldn't get marks off for spelling. Okay, and then part 2, part 2 of question 5 is again a little bit more difficult. And it says, in a titration experiment, it was found that an average of 15.2 centimetres cubed of 1 mole per litre sodium carbonate was required to neutralise 20 centimetres cubed of sulphuric acid. And the balanced equation for the reaction is shown below. So we've got a balanced equation, we've got lots of numbers. It says calculate the concentration in moles per litre of the sulphuric acid solution. And it's a 3-mark question. So again, we've got a 3-mark question with a balanced equation. This is one of our calculations from balanced equations, and actually more specifically it's a titration calculation. So we should be revising titration calculations here if you were stuck on this question, but I will set a little bit of work to do that for everyone. Okay, so just like with the previous balanced equation question, the thing you need to do with these is first of all work out what substances in the equation the question is talking about. Second of all, do a data column for each question, for each substance, and then you're going to work out the moles, use the mole ratio, and then work out what the question is asking you at the end. Sounds simple, I know, but it will come with practice. Okay, so it's telling us that we used an average of 15.2 centimetres cubed of sodium carbonate. Now you should recognise Na2CO3 as sodium carbonate. So it's giving us information about that, and it's saying was required to neutralise 20 centimetres cubed of sulphuric acid. Okay, so you should again recognise H2SO4 as sulphuric acid. So we've worked out which substances it's asking about or giving information about. We've circled them, and then we're going to do a data column for each. So you can either write the names or you can write the symbols. We've got our H2SO4, we've got our sodium carbonate, and then we need to think about what information we're being given. Now, if you got a little bit mixed up with this and started trying to work out masses and GFMs and things, but you should recognise it's starting to talk about moles per litre, and it's also giving us volumes, values in centimetres cubed, which you should recognise as a volume, not a mass. So for our sulphuric acid, we had a volume of 20 centimetres cubed, and it's asking us to calculate the concentration in moles per litre of the sulphuric acid solution, so that's a question mark. For our sodium carbonate, it's giving us a volume of sodium carbonate, and it's giving us 1 mole per litre. A lot of you thought that this was a number of moles, but you need to pay attention to the full units. Moles per litre tells us that it's concentration. So our concentration is 1.0 moles per litre. So you need to make sure you know the units of each of these different quantities and what those units mean. I've said already in my previous video that if you've got a balanced equation, you're going to need to go via moles. Okay, so you're going to need to look at your equations for moles and you need to figure out which one to use. So we've got concentrations and volumes, so we're going to use N equals CV. Okay, so we're going to start. Step 1 is going to be to calculate the moles of the thing we have most information for. Now at the moment we've got most information for the sodium carbonate. We're going to use N equals CV, that's just straight out of the data book. Our concentration is 1, and our volume, we need to remember to convert to litres by dividing by 1,000. So that's going to be 0.0152 litres. So I'll just check that. Never just assume, always double checking your calculator. So that is 0.0152. So 1 times 0.0152, which equals, we're just timesing it by 1.0152 moles. Okay, so our step 1 is calculating the number of moles for the thing we have most information for. Step 2 is going to be the mole ratio. Okay, so our mole ratio is for sodium carbonate to sulfuric acid. Well, if we look at the balanced equation, there's no numbers in front, so it's just a 1-to-1 ratio. So if we have 0.0152 moles of sodium carbonate, we're going to also have 0.0152 moles of sulfuric acid in this reaction. So we can substitute in the number of moles, 152, and that then gives us enough information to calculate the concentration. So N equals CV. Do your little triangle if you want. N is on its own, so N must go on top. N is CV. Concentration must be, therefore, number of moles divided by the volume, which is going to be 0.0152 divided by, not 20, because we need to convert to litres, 20 divided by 1,000. .02, so 0.0152 divided by 0.02, and that is going to give us 0.76, and the concentration is measured in moles per litre. Okay, so again, I've just double underlined my final answer there. Like I've mentioned, I will set you a little bit of work, because everyone found this quite hard, so I'm going to set you a little bit of practice of this type of calculation so that hopefully you can get it next time.